So here again is the graph of the natural log of x, and what I've drawn over here is the derivative. And you've noticed I've scratched off this portion here, but that's because we can't actually have a derivative of a piece of graph that doesn't exist. So what's interesting is that you're going from a parent function, the natural log of x, to the parent function f prime of x equals 1 over x. Now notice the x is greater than 0, which is why I scratched this portion out. I wanted you to see it so you know which graph it's going to and that you've seen it before, but it is not part of the derivative. So why is this happening? Why are we going from 1 over x to 1 over x? If you look at this, the slope is always positive. So you'll notice that my derivative is always in this quadrant. It's positive. The slope is decreasing. It's flattening out. It's headed towards 0. It started off really steep and then it's headed towards 0. So it started off with really high y values. And as the slope decreases, my y values decrease. So the derivative of the natural log of x is 1 over x, but you will only be taking derivatives of things that have a positive argument inside. That means what's inside of the natural log of x must be greater than 0. So if we go on to the chain rule, the derivative of the natural log of u is 1 over u times your u prime, which is a du dx. So some people like it as 1 over u times du dx or 1 over u times u prime. But if I have 1 over u times u prime, that's simply u prime over u. And this actually should be u is greater than 0, so I will go fix that on your slide. And then what I have here is the derivative of the natural log of the absolute value of u. So what if there are absolute value symbols around it? Turns out nothing changes. It is the exact same thing. So it is still u prime over u, so you'll see problems with absolute value and problems without. Either way, the derivative is the derivative of the inside function over the original function. It's whatever you're taking the natural log of.